Hey everyone, my name is McKenna Davari, and today we'll be talking about if life can be sustained on other planets, or if life is impossible on other planets other than Earth today. So let's dive right into it. We're first going to talk about Mercury. Life couldn't exist on Mercury without serious terraforming. Mercury has large temperature swings. The side facing the sun can reach temperatures of 900 degrees Celsius. The dark side can drop to temperatures similar to that of deep space. Because of this, liquid water cannot exist on Mercury, and water is a requirement for life. Mercury also has frequent asteroid impacts. Because Mercury lacks an atmosphere, these impacts are highly unpredictable and highly dangerous. Then, all life would be destroyed by these asteroid impacts. In order for there to be life on Mercury, Mercury wouldn't have to rely on water and could stand rapid and violent heat swings. Then, life could happen. You can also terraform Mercury and give Mercury an atmosphere. An atmosphere would be difficult to maintain due to Mercury's small mass, but by adding gravity enhancers, you would have what is necessary in order for Mercury to maintain an atmosphere. But Mercury already has a magnetic field. In order for us to stabilize the temperature in Mercury, this would require the movement of energy from the warm side of the planet to the dark side of the planet. Once there is an atmosphere, it is not necessary to move that much energy because some energy will be kept in the planet. Once the energy is around the planet, most of life should be reflected. Then, water needs to be introduced along with terrestrial life. The next planet we are going to be talking about today is Venus. Venus has a surface temperature of over 800 degrees Celsius. Venus also has a very heavy atmosphere, which is the equivalent of 94 times our sea level pressure. This means a human would need a heavy shell of protection in order to survive this atmospheric pressure. Venus also has corrosive clouds of sulfuric acids. And also, Venus has volcanoes under the surface, which can cause the mantle to push up and crack the crust, which means no land or life forms can live on the ground of Venus. Venus also has hurricane-force winds and lightning storms. It is said that life on Venus was like Earth, but due to these climate patterns, this destroyed this Earth-like environment. Also, the surface can melt lead, so no humans or other life can possibly roam the surface of Venus. It is possible for humans to live in the clouds of Venus by having a device that can deflect its solar radiation and can withstand lightning storms and heavy winds. Because life on the surface of Venus is impossible because the surface can melt lead, which can cause the extinction of life. The next planet we are going to be talking about today is Mars. For the long term, we'll need to figure out how to extract water from underground supplies and use that to generate breathable air and rocket fuel. And once we've reduced the risk of suffocation or dying of dehydration, we'll need to consider our food sources, as we'll be outside the delivery area of everyone except Planet Express. Care packages could be shipped up from Earth, but that's going to come with a hefty price tag. Also, we'll need to consider producing our own food too, since we cannot possibly hope to ship it all on a regular basis. Interestingly, Martian soil can be used to grow plants once you supplement it and remove some of the harsher chemicals. NASA's extensive experience in hydroponics will help. To strive on Mars, the brave adventurers may want to change themselves or possibly their offspring. This could lead to genetic engineering to help future generations adapt to the low gravity, higher radiation, and lower air pressure. And why stop at humans? Human colonists could also adapt to their plants and animals to live there as well. Finally, to take things to the next level, humanity could make a few planetary renovations. Basically, we could change Mars itself through the process of terraforming. To do this, will need to release megatons of greenhouse gases to warm the planet, unleashing the frozen water reserves. Perhaps we'll crash a few hundred comets into the planet to deliver water and other chemicals too. But there are dangers to Mars as well. Solar flares can represent short-term hazards for crews heading to Mars and on the surface of the planet. But such flares can be detected in advance, and temporary radiation shelters used to largely protect the crew. A longer-term hazard is the general exposure to higher levels of radiation, whether it be from the sun or sources external to the solar system. We can minimize these effects, but there will be increased exposure and thus a higher risk of cancer later in life. We are now going into the outer planets of our solar system. First, we're going to take a look at the conditions of Jupiter. Jupiter is a gas planet and is composed mainly of hydrogen and helium. There is virtually no water to support known life forms. The planet does not have a solid surface for life to develop anywhere, except as a floating microscopic organism. These free-floating organisms can only exist at the very tops of the clouds due to the atmospheric pressures that is more intense than we have ever seen on Earth. While the cloud tops could harbor life that is resistant to solar radiation, the atmosphere is always in constant chaos. The churning would eventually expose any organisms to extreme pressures near the core, thus killing any that may develop. Should an organism find a way to resist atmospheric pressure that reaches 1,000 times what is here on Earth, there are the temperatures close to the planet's core. Gravitational compression. As heated areas near the core to over 10,000 degrees Celsius, it is so hot in some areas that hydrogen is in a liquid metallic state. While organisms on Earth live in areas near volcanoes, the temperatures there do not approach Jovian levels. But Jupiter isn't completely inhospitable to life as we understand it, but its moon Europa has been proposed as a possible habitable source. It is thought to have a large amount of water ice on its surface, some of which covers a proposed ocean of water slush. The conditions under the water ice could be harboring microscopic life according to scientists. The question is there life on Jupiter? Well, there could be life on Jupiter, but there's no way that life as we understand it could exist on this gas planet. The possibility of life can only exist on Jupiter's moon, Europa. The next planet we are going to be talking about today is Saturn. The planet is comprised almost entirely of helium and hydrogen, with only trace amounts of water ice in its lower cloud deck. Temperatures at the top of Saturn's clouds can dip down to negative 150 degrees Celsius. But temperatures do get warmer as you descend into Saturn's atmosphere. But the pressures increase too. When temperatures are warm enough to have liquid water, the pressure of the atmosphere is the same as several kilometers beneath the ocean on Earth. To find life, you will want to take a good look at Saturn's moons. They are comprised of significant amounts of water ice, and their gravitational interaction with Saturn probably keeps their interiors warm. And Saturn's moon Titan has lakes and seas of hydrocarbons, thought to be the precursors of life. In fact, Titan is very similar in composition to Earth's early history. Hydrocarbons have also been detected across the surface of Saturn's moon Hyperion. There might not be life on Saturn, but there is enough intriguing locations to keep us busy for years. The next planet we are going to be talking about today is Uranus. It wouldn't be possible to have life on Uranus because Uranus, it's a giant planet made mostly out of ice with no solid surface, and it has an atmosphere with a freezing temperature of negative 224 degrees Celsius, along with a core heated up to 4,700 degrees Celsius. This makes it a very unlikely place for any life to exist, it's very unlikely that life exists on Uranus, not only because of its dangerous characteristics of this planet, but also because of the intense pressures that would crush life. In addition, it has been noted that there's no process to supply organisms with energy on Uranus. The last planet we're going to be talking about today is Neptune. In order for life to be on Neptune, we have to find liquid water on it. But this planet does not have a source of liquid water, as its surface has a temperature of 55 Kelvin. That's very cold. There's no way liquid water could exist. But as you travel down into Neptune's interior, the temperatures and the pressures increase. And there could very well be a point inside the planet where water remains as a liquid and life could exist inside of it. Of course, this region would have to be hundreds of kilometers below the surface and would be impossible for us to study. For now, it remains a mystery to us if life could exist on Neptune.